lecture we have done the properties of determinant. Today we are going to do the application of determinant. So the first topic under the application is Cramer's rule. Basically, when we started determinants, I told you that determinants help us to find the solution of equation in a plane. So students, in the previous class you have done that if you have to find the equation, if you have to find the solution of the equation, you use substitution method or elimination method and stuff like that. We can also use Cramer's law to find that solution. So basically in the earlier classes you used to deal with solution with the equations with two variables, that is x and y. Here we will consider three variables, that is x, y and z. So let us consider the equations. So let the three equations with a1x plus b1y plus c1z is equals to d1, a2x, b2y, c2z is equals to d2, a3x, b3y, c3z is equals to d3. So these are the constants. d1, d2, d3 are the constants. Coefficient of x are a1, a2, a3. Coefficients of y are b1, b2, b3. Coefficients of z are c1, c2, c3. So students, first of all, we will find d, dx, dy and dz. How we will find d? We will simply write all the coefficients in the determinant form except the constants. जितने भी x, y, z के coefficients हैं हम उसको determinant form में लिख देंगे. Then how we will find dx? So instead of x, so these are the coefficients of x. So instead of coefficients of x, I will write all the coefficients, all the constant coefficients, that is d1, d2, d3, and then I will form a determinant. My y and z determinants, y and z coefficients will remain same. Now if I have to dy, then instead of coefficient of y, I will write constants and x and z coefficients will remain same. In the similar way, if I have to find dz, I will replace the coefficient of z by the constant coefficients. So this is how I can form the determinant d, dx, dy and dz. You already know how to find the value of the determinant. After finding the values of determinant, how we can find x? Simply by dx by d. I will find its value, I will also find its value. I will simply divide both of them and I will get the value of x. If I have to find the value of y, then it will be dy upon d. If I have to find the value of x, it will be dx upon d. And one main condition here is my d cannot be equal to 0. Why? If my d will be equal to 0, then these solutions, then the denominator will be 0 and it's not possible. So students, this is how we can use the Cramer's rule to find the solution of equation in a plane. So students, let's see how the equations or how the lines, basically these equations are the equations of line, how lines are can be represented in a plane. For example, this is a plane. So either the three lines will intersect each other at a common point. First is this. Basically this is this method only when all the lines intersect. Second can be if they are parallel. Students, see, if lines will be parallel, there will be no solution, or we say them inconsistent. If they have a solution, we say them consistent. then you can see they will have infinite many solutions. This also falls under consistent. Why it falls under consistent? Because they have some solutions. They have infinite many solutions. In this condition, it will have only one solution, and in this condition, they will have no solution. So, how we can find that the given equations have consistent solution or non-consistent solution? We can find that with the help of determinant D. So, what was D here? D was all the coefficients of x and y, the determinants of coefficients of x, y and z. So, let's see. First, we will say when determinant is non-zero. When determinant is non-zero and d1, d2, d3, basically d1, d2, d3 are dx, dy and dz. dx, dy and dz. They are also non-zero. Like this case. अगर मेरे पास d भी non-zero है और dx, dy और dz भी non-zero है, then I have consistent, unique and trivial. Trivial means when I have only one solution. तो मेरे पास ये केस होगा. If my d is non-zero but dx, dy, dz is equals to 0, then I will have consistent solution and trivial. But see, if my dx, dy, dz will be 0, so this term, if my dx is equals to 0, this term will become 0. Y will also become 0, z will also become 0. So the solution here will be 0, 0, 0. That means origin. So that means all the lines pass through a common point called origin. So now let's move to the second part where my d is equals to 0. So if my d is equals to 0, I will not follow this. So I can't follow this pattern. So what will happen in that? I will find dx, dy, dz. If all my dx, y and z are equals to 0, then I will have consistent solution and I will have infinite many solutions. That means all the lines are coinciding. They are overlapping each other. When my d is also equals to 0, when my d is also equals to 0, the value of d as well as dx, dy, dz, they all are equals to 0. That means that all the lines are overlapping each other or they have infinite many solutions. So here the fourth type is if my d is equals to 0 but d1, d2, d3 all are not equals to 0. जब मेरा d तो 0 है लेकिन बाकी सब चीजें 0 नहीं है, then I have inconsistent solution or I have no solution. That means then I will have a solution like this. तब मेरे पास line parallel होंगी, they will not intersect each other, therefore I will not have a solution. So this was basically the method how we can find the solution of equations in a plane, as well as how we can see with the help of values of d that either they are overlapping, intersecting or they are parallel. Now let's see some of the examples related to the Cramer's law. So the first question is I have to find the solution of the equation. So I have already done half of it. So what will be my d here? All the coefficients of x, y and z. So it will be 2, 1, 3. Coefficients of x, coefficients of y, minus 1, 2, 1, minus 1, 2, 1. Coefficient of z, 1, 3 and minus 4. So after expanding the determinant, I have found the value and it comes out to be minus 40. In the similar way, if I have to find dx, what will I do? Instead of coefficient of x, I will write the constants, that is d1, d2, d3. So here d1 is 1, d2 is 8 and d3 is 1. So one thing we have to notice is that d1, d2, d3 should be on the other side of the equal to sign. Equal to sign के इस तरफ होने चाहिए d1, d2, d3. Okay, because then the sign positive negative signs ऊपर नीचे हो जाएंगे. Then instead of x, coefficients of x, I have put all the coefficients d1, d2, d3. In the similar way, when I wrote dy, instead of coefficients of y, I have wrote all the coefficients of all the constant coefficients. Similarly, here instead of coefficients of z, I have wrote all the constants. So after expanding it, I have already found the value. It comes out to be minus 40. dy comes out to be minus 80 and dz comes out to be minus 40. So to find x, so the formula says it is dx upon d. So my dx is minus 40, my d is minus 40. It comes out to be 1. Y dy upon d. dy, so dy is minus 80 upon minus 40, sorry. It comes out to be 2. And z, dz upon d. So this is minus 40 upon minus 40, this is 1. So the value of x, y, z comes out to be x is 1, y is 2 and z comes out to be 1. So this is how I find the value of x, y and z using the Cramer's rule. Now let's see question number 2. So here the coefficients are in the variables are in the denominator. Let's see how we can find this solution. So this is 1 by x upon 1 by y upon 1 by z. Similarly here also the variables are in denominator. So I will take, let 1 upon x is equals to a, 1 upon y is equals to z is equals to b and 1 upon z is equals to c. I have taken a, b and c coefficients. 1 upon x is equals to 8, 1 upon y is equals to b, 1 upon z is equals to c. So the equations will become a plus b plus c is equals to minus 2, a minus 2b plus c is equals to 3. जो 1 by x है वो a बन जाएगा, यहाँ पर जो y 1 upon y होगा वो b बन जाएगा and 1 upon z will be c. So the next will be 2a minus b plus 3c is equals to minus 1. So we have done this to form the equation like these. Now this is easy to solve the equation and there will be no confusions. So now let's see. So d will be the coefficients of a, b and c. So here my d will be 1, 1, 2, 1, minus 2, minus 1, 1, 1, 3. Now let's expand this. This will be 1, minus 6 plus 1. Whenever I take second element, I always take it with the negative sign. Minus 1, 3, minus 2. Plus 1, 3, minus 2. So it comes out to be 1, minus 5, minus 1, 1, plus 1, 1. So this will be minus 5, minus 1 plus 1. So this comes out to be minus 5. Let's see what will be the value of dx. So dx will be, instead of coefficients of x, I will write d1, d2 and d3. It will be 2 minus 2, 3 minus plus minus 5. So this will be 10 minus 10 minus 5. So it comes out to be minus. Yes, there's one correction. So this is not 3 minus 2. This will be 1 into minus 1 into 1 will be minus 1. 2 into minus 2 will be minus 4 minus minus plus 4. This will comes out to be 3. So this will be 3. Minus 5 minus 1 will be minus 6 plus 3. It comes out to be minus 3. So I've already found dy, its value comes out to be 5, and dz, its value comes out to be 6. So x will be dx upon a will be here, because we are taking all the coefficients as a, b and c. So here a will be, so instead of dx you can write here a, instead of y you can write b, and instead of z you can write c. So your a will be dA upon d. So your dA is minus 5 upon minus 3, which will be 5 upon 3. Your value of v will be bd upon d. It will be 5 upon minus 3, or I can write it as minus 5 upon 3. And value of c will be dc upon d, which will be 6 upon minus 3, or I can write it as minus 2. So I have found the value a, b and c, but initially my question was in an x, y and z, so I have to find the value of x, y and z. So if 1 upon x was equals to a, therefore 1 upon x will be equal to 5 upon 3. So here my x will be 3 upon 5. In the similar way, 1 upon y was b. So it's minus 1 upon y is equals to minus 5 upon 3. So my y will be the reciprocate. It will be minus 3 upon 5. In the similar way, 1 upon z was equals to c. So 1 upon z is equals to minus 2. So z comes out to be minus 1 upon 2. So this is the value of x, y and z. It was a very simple question. Only if the variables are in reciprocation, or if they are in denominator, we simply take 1 upon x is equals to 8, 1 upon y is equals to b, 1 upon z is equals to c, and then we solve rest of the question. Let's see the third part, third question. So the third question says, find k if the following equations are consistent. Consistent means that they have a solution, and if you will observe carefully, they just have two variables x and y. Student, if a question like this comes, we simply write the equations in the determinant form, including the coefficient. This is 2 minus k and minus 3. And if they are consistent and the coefficients, the constants are equal to 0, then we simply write the determinant is equals to 0. So the value of determinant will be 1, 3, 2, 2, 4 minus k, 1 minus 2 minus 3. Let's see once again. So the equations was equation in two variable. All the constants were 0 here, and I was given condition that they are consistent. So if they are consistent, I simply write the equations in the determinant form and I put it equals to 0. If there would have been only two equations, अगर ये third equation यहाँ पे नहीं होती और सिर्फ दो equations होती, you could have simply solved it by elimination method or substitution method. But if there are more than two equations, applying the Cramer's rule is the simplest form. So I will simply open up this determinant. I will simply find the value of the determinant and will put it equals to 0. So it will be 1 minus 12k minus 2k minus 3 minus 6k plus k plus 2 minus 4 is equals to 0. So this comes out to be minus 14k minus 3 minus 5k plus 2 into minus 8 is equals to 0. So this will be minus 14k plus 15k minus 16 is equals to 0. So k minus 16 is equals to 0. So the value of k will be 16. So these were some of the examples related to the Cramer's rule. The second application is area of a triangle. We can find the area of the triangle if the coordinates are given using the determinant method. So if the coordinates are a, b and c and coordinates are x1, y1, x2, y3, x2, y2, x3, y3, then we put the coordinates in the form of determinant with the 1 by 2 in the multiplication, and when we will solve this determinant, the value of the determinant will give us the area of the triangle. So let's see, I have put the coefficients of the coordinates of x in the column 1, coordinates of y in the column 2, and in the column 3 there is only 1 and 1. I can write the determinant in this form also, or I can write the determinants in row form also. Here I have simply done the columns are converted into rows. We have seen in the properties of determinants that if rows and columns are interchanged, the value of the determinant remains same. So either I can write the values of determinant in this way, or in this way I will get the same answer. So we know that area is never negative. So the area that this triangle will occupy can never be negative. So in calculation, if the value of determinants is negative, we automatically take it as positive. Second, if a is equals to 0, if the value of area becomes 0, what that means? That means that the point or the coordinates that are given are collinear. So what are collinear points? The points which lie in the straight line are collinear. Obviously, if they lie in the same line, they cannot form a triangle. Therefore, to see if whether the points are collinear or not, we simply use the formula of area of triangle. If the area comes out to be 0, that means the points are collinear, that is, they lie in the same line. Third thing that we have to keep in mind is if we have to find a constant k. Let's see in question number 2. Find k if area is 4 square units. So here I will consider both positive as well as the negative value of the negative value of the area. Why? Because we are finding here k. K की value जो इसमें से कोई होगी that can be negative as well as positive. So this is a very easy topic. Let's solve some of the examples. In first question, it simply says find the area of the triangle if coordinates are given. Let's represent this in a determinant form. So area will be half. So this is x1 y1, x2 y2, x3 y3. So x1 is 4, x2 is 0, x3 is -1, y1 is 5, y2 is 7 and y3 is 1. Rest, this last column will be 1, 1, 1. Let's solve this. So first it will be 4, 7 minus 1 minus 5, 0 plus 1 minus 1, 0 minus 7. So it will be half. 4 into 6 minus 5 into 1 minus 1 into minus 7, which will be half. 6 2s are 24 minus 5 plus 7. 24 plus 7 is 31, or I can say half. Minus 5 plus 7 is plus 2. 24 plus 2 will be 26, and if I will do the cutting, it will come out to be 13. We know that if we are finding the area, it can be in meter square, centimeter square, millimeter square. As units are not given here, we simply write square units. So the answer will be 13 square unit. I have used this type of determinant in finding the area of the triangle. You can also use this pattern. So next question says, find K if area is 4 square units. Let's do it here. So the coordinates are 2, k minus 5, 7 minus 1, 4. Let's put this in the determinant form. 2 minus 5 minus 1. K, 7, 4, 1, 1 and 1 is equals to plus minus 4. I told you earlier, if we have to find an unknown constant, then and if area is given, we consider both positive as well as negative value of the area. Because in determinants we have seen that the values can be positive as well as negative. Let's open this determinant. This will be 2. Sorry, I forgot half. 2, 7 minus 4 minus k minus 5 plus 1 plus 1, 5 4s are minus 20 plus 7. So this will be 1 by 2. 7 minus 4 is 3, and it will be equal to plus minus 4. Minus k minus 5 plus 1 is minus 4 plus 1 minus 20 plus 7 is minus 30. So this will be 1 by 2, 6 plus 4k, 6 plus 4k minus 13 is equals to plus minus 4. 6 minus 13 will be minus 7. Plus 4k is equals to plus minus 4. So this comes out to be minus 7 plus 4k into half. First we will consider positive of 4. So this will become, this is the first case, so this will be minus 7 plus 4k is equals to 8. 4k is equals to 7 plus 8. K comes out to be 15 upon 4. So in case 2, we will consider the value is equals to minus 4. It will be half. Minus 7 plus 4k is equals to minus 4. This will gives out to be minus 4 2s are 8. This will be 4k minus 8 plus 7. So the value of k comes out to be minus 1/4. So whenever an unknown is given, we always get two values of k. So this was again simple. We have simply put the coordinates in the determinant form, and the area that was given, we have taken both the positive as well as the negative value. Let's see the last question. Show that points are collinear. We have seen earlier in the video that if points are collinear, that means the area of the triangle will be 0. So simply we have to prove here, or if we will prove that area is equals to 0, then the points will be collinear. So let's put the points in the determinant form. 5, 10 minus 5, 0, minus 3, 6, 1, 1 and 1. So for area it will be half. Half 5 minus 3 minus 6 minus 0. If I will multiply anything with 0, it will be 0 only. Plus 1, 60, 10 into 6 is 60, minus 15, half into 5 into minus 9, 0, plus 1 into 16 minus 60 minus 15 will be 45, minus 45 plus 45, so area comes out to be 0, hence points are collinear. So here you can see minus 45 plus 45 will be 0, and if we will multiply half with it, it will comes out to be 0 square unit only, and we know that if area is 0